So we were talking about a star topology, okay, in which all the nodes are connected to the centralized device and they have a dedicated connection to that, to the centralized device. So what would be the advantage and disadvantage of this network, this type of topology?
Saying that the disadvantage here is this is just through one central connection. So if that connection, if the switch maybe without the hub or whatever got broken, so we cannot share anything.
We can say if the centralized device
is not working.
Yes. Not working, the connection shuts down. Okay. Other than this, there was a disadvantage in bus topology that if a device particular stops working or the connector of that device stops, then the connection goes down. Or if the want to expand the network, in that case too we will have some downtime, because if I'm connecting two devices between 3 and 4 in bus topology, then we need to break the cable, we need to connect, add a connector there. Okay, but here in star topology's case, we don't have to worry about that. If I want to add, if I want to expand the connection, I want to add a device, I just need to connect a different cable to the hub, to the switch or whatever we are using. Okay, so we can say that it is easy to manage, easy to expand or maintain the network, because every cable, every node have a separate cable of their own. Okay, so easy to manage, expand and maintain the network, as every node have a separate cable to connect with the centralized device.
But still, the connection will be limited.
Yeah, depending on which type of device. Like if we are using a switch which only have 8 ports, then the number of devices will only be 8. If I want to expand it, then I need to connect two switches, or if I want to expand it more, then I need to purchase some extra switches. So we can say the performance of the network depends on the device we are using as the centralized device. Like if we are using a hub, in that case, hub what does? It does broadcasting. So it will, whenever some data is sent to hub, it will just ask all the devices, like what is your address, who have this address, right? So once we get reply from there, then it will send the data. The connection performance will be a little bit slower. If we are using a switch, in that case, let's say 4th machines, I want to send data to first one, it will send the data to switch, and then switch checks the address in its table which it maintains and send the data there. So that will be faster compared to hub. Also, fault identification is simpler. Like if there is some fault in a cable, then I can directly identify it, because every connection, every node have a different connection.
It's a different. Yep.
So if only machine 5 is going down, then I know that there's some issue with either the cable of the machine 5 or the machine 5 itself.
It's one of the advantages then.
Right, it's one of the advantages. So let's directly write fault identification is easier. Okay.
Yep.
But the cables that we are going to require here is a little bit extra, because we need to provide a dedicated connection to all the servers.
Yep.
So cable costing is more. Okay. So this one is our third topology, that is star. After star topology, next one is our ring topology.
Yep.
So as the name suggests, it's nothing but a ring. On that ring, we are gonna connect our nodes. Let's say I'm connecting 4 nodes, 1, 2, 3, and 4. So generally it is in you can say shape of a ring, but it have a loop there.
Yep.
Okay. This one is our machine 1, 2, 3, 4. So ring topology, also known as token ring topology. Ring topology, or we can say token ring topology. So like some places have a token system. Like if you want to purchase something, or if you go to a doctor's place sometimes, so they have a token number. Like if you first get the token number, and once your token number is called, you will go there.
Yep.
So in that, you have a fixed place. You are sure that the data will go. You will go in there. Okay, once you have got the token. So here also a logical unit is being used. A logical unit known as token is used to send the data. That token will keep on going, moving in clockwise direction. Okay. Just a minute. So the token will keep on going in clockwise direction, and if some system wants to send the data, it will capture that token, and then you can say map the data behind the token and then send the token to the destination. Okay. So let me write it. Moves in clockwise direction.
Clockwise direction.
So if a particular system wants to send data to any other system, then it will capture the token and then send the data with the token, transmit the data with the token to the destination. So what will happen here? Unicasting, multicasting, or broadcasting?
It's not broadcasting since it's sending with a token.
It's a
Your voice is breaking a little. Just a minute. Yeah, what were you saying? Hello.
I said it's multicasting.
Yeah, it can be multicasting
but
or
it's
broadcasting, depending on the situation.
broadcasting.
Generally, it will be doing the broadcasting thing. Like
But
if,
it's sending with the token.
yeah, it is sending with the token, but it is taking the same path.
Yeah.
So the data will go from here. Let's say
Yeah.
machine
Okay,
one
yeah.
want to send the data to the fourth one. It captured the token, mapped the data there, and then send the token. It will first go to machine 2, check whether machine 2 have the destination address or not. If it is not, it will go ahead to the third one, again check. If not, then go to the fourth one. Once it states the destination, it will deliver the data there. Okay. So the data will reach to the destination, and the token will come back to the source.
Yeah.
And just hold on a minute. So now the data has once the data has been delivered to the destination, the token will come back to the first machine, to the source, and provides the acknowledgement that the data has been delivered. Unlike bus topology, where we didn't get the acknowledgement of the delivery of data. Okay. And once it has been verified that token is discarded, a new token has been generated, and then it will again starts moving in the network. If someone wants to send the data, they will capture it and then send the data.
Yeah.
Like if right now machine 1 was sending the data, if during that time machine 2 wants to send the data, they will not be able to send it, because right now a one token is running in the system, in the network. Once it has been discarded, there are no tokens that is being used in the network right now. Only then the second machine will start sending the data.
So just one token at a time.
Yeah. So with because of the token, the chances of the collision is 0. Okay. So no collision will be there. Other than that, it does broadcasting mainly, and yeah, disadvantage could be like if the cable is broken, if the loop is broken, then connection goes down, because the token will not be able to reach its source or destination. Okay. So if the cable is broken, the whole connection goes down.
So there's no way to trace. There's no way to ping which one is done or not.
Right. You can try it, because if the token is here on the first machine, then you can ping on second one. But if the first machine don't have a token, and if you try to ping on the second machine, you will not be able to do that, because it might be possible, like it could be like this. Let's say right now the token is on second machine, just for example.
Yeah.
So token is on second machine, and your cable is broken here between third and fourth. So only second machine can try connecting the third one, and even then he will not get the acknowledgement. The data will be delivered, but he will not get acknowledgement that whether the data was delivered or not.
Okay.
So it is as good as down. Okay. Because it only travels in clockwise direction. So it will not be able to create the loop here. So if the cable is down or any system is down, in that case too, the connection will be down because the loop will not be created there. Okay.
Terrible connection.
And there is no need for a particular system or a device to manage the flow of the traffic. Like in star topology, we had that switch, right? So using that, the connection was maintained. Using that, the data was delivered. But here we don't have such device. Okay. So these are the advantages and disadvantages. And one more thing, as it is delivering data one by one using only a single token, the connection will be network speed will be slow. Okay. So this is our token ring topology, or we can just say ring topology. After ring topology, the next one is our dual ring topology. So it is almost similar, only a single difference is there. Erase it a little bit. So now we have two rings this time instead of one.
Yep.
One ring, you can say the primary ring that will take the data in clockwise direction, and the secondary
And
ring
the
that
other
will
one,
take the anti-clockwise direction.
anti-clockwise.
But the secondary ring will only be used when the primary ring is down. Okay.
Yeah.
When the primary is down.
Yeah, and when the primary is down. If the primary is working fine, the secondary will just stay as it is. It will not be used like forever if it is if the primary ring doesn't goes down. Okay, but you can just say it is a backup ring which can be used in case of any break in the primary ring. Okay, so let me add it here only. Dual ring topology. So two rings will be there, primary and secondary. Consists of two rings, primary and secondary. Okay. The first one, that is primary ring, will send the data in clockwise direction. Whereas the secondary ring
And
in anti-clockwise.
anti-clockwise.
And the secondary ring will only be used if the primary is down. Secondary ring will only be used if the primary ring is down. Down, or you can say it open. Okay.
Yep.
So this is our ring topology and dual ring topology. So let's check. Okay, it's full. Okay, the next one is our mesh topology. One, two, three, four, five, six. Mesh topology. Okay, so in mesh topology, we have again two types, and those are, it could be either partial mesh
Yep.
or full mesh. So depending on which type of topology we are using, it might send the data using by what we say, it might broadcast the data, or it might unicast the data depending on the situation, or multicast.
Yep.
Okay, so mainly let's create the diagram here. And 1, 2, 3, 4, and 5. So this right here is the diagram of our full mesh topology. So in this topology, we will be using routers to send the data, and router will select the best possible path. This also needs to be added. Now it is full mesh topology. So in full mesh topology, all the nodes have a point-to-point connection. Like one is directly connected to 5, 4, 3, and 2. Similarly, 2 is connected to all the devices. Okay, so all the devices have a point-to-point connection between each other.
Yep.
So let me write it here.
Is there a full mesh?
Yep, this one is full mesh.
This is full mesh.
So all the nodes have point-to-point connection with one another. Okay, router will be used to select the best possible paths to destination. So router will be used, and router will do its works and select the best possible path to the destination, which will in turn, you can say, results in less traffic in the network. Okay, and in case of full mesh, now it might be possible that the routing protocol that I'm using says to the router that the best possible path from 1 to 5 is this one, or it might be possible that the different routing protocol says that this one is the best path. So it depends on a logical topology, like how we will be configuring the router. On that, it will depend like from where the data will travel. Okay, so this is our full mesh topology. In case of partial mesh,
Yep.
let's remove some of these. Okay. Yeah.
So the router will determine the path you want to take based on configuration. I mean, the switch or the router will determine the path to take to the destination.
Right. The switch, the router will define which paths to take.
Based on configuration, though.
Right. Based on the configuration which we will be doing later, like which routing protocol is being used.
Okay.
So in case of full mesh, every node can carry its load. Like if one wants to send the data to 5, it have a dedicated connection and send the data from there. Okay.
Yeah.
If we are using partial mesh, in that case, if first machine wants to send the data to the fifth one, it cannot directly send the data. It needs to go to either the second, then the fifth, or third, and then fifth. And it might be possible, it could be like this. So let's see, even this one is not connected. And now machine 3 wants to send the data to the machine 2. So it only have a single path. No, two paths. It needs to go to either fourth machine, then second, or it first needs to go to the fifth one and then the second.
Sorry, in full mesh, how many router is being used? Or in this scenario?
No, in full mesh, like let's say this one is a different network, this one is a different. I'm just taking them as a node.
Okay.
Okay. So they all are different.
Different network. Okay.
Right. So best example for this mesh topology, you can say, is the internet. Like if you are connecting with the ISP's network, you are only connecting to your home router, not anywhere else. After that, ISP takes you to anywhere in the world.
Yeah.
Okay. So you can say it is fully connected, but the cable costing will be more here. Okay. You can say depending on the traffic nearby you, the performance will also decrease. Like sometimes the network speed also goes down. So when that happens, that means the devices in the network increased. So because of that, the bandwidth was distributed to all of those. Like if you sometimes use the internet at night, then the speed might be higher, or during morning the speed might be higher. Okay.
Yeah.
Am I audible?
Yes.
Yeah. Yes.
So let's write it here, like fully connected with outside world. We can say the cabling is more and complex. Okay. Other than this, bulk wiring is needed. That is fine. Installation will be a little bit difficult in installation and configuration. Installation and
Can you also give me one more example for partial mesh, like a real example, real life example?
Real life example, you can say in metropolitan area network or in a campus area network, if you want to connect different LANs. Okay.
Yeah.
So let's say we have, let me just create just diagram here. This one is my first LAN network, this one is my second, then third, and then fourth. So here I'm gonna put a router at this place, this one. So all the LANs have a router now.
Yep.
And if they want to send the data, it might be possible that I connect them like this. Physically, the cable is there in what we say, the full mesh connection is there.
So each of the router you connect to each other.
So every router is connected with other. So if I want to send the data from this one, let's say this one is first, second, third, fourth. So if I want to send the data from the fourth to the second, so it depends on the configuration of this router, like how the data will be sent. If according to this router, this path is best, it will send the data there. If according to this router, this path is the best, then it will send the data from there. Okay. So in that case, it all
like all the routers are configured on one router, and then they will choose which path is the best.
No. Configuration needs to be made on all of these. Like if we talk about routing protocols, we have a static routing protocol in which we need to enter each and every route one by one. You needs to know about every network which is available, every you can say different networks IP address which are connected in your premises. Then you need to make entry on this one, then on this one, like four networks are there, so 4 entries here, 4 here, 4 entries here, and 4 here. So you need to make around 16 changes if you use the static routing protocol. If you use dynamic routing protocol, in that case you just need to tell this router that with this only this network is connected. For this one you need to make entry for this network here, for this one, and here for this one. So now you need to make one entries on all the routers. After that, they will send the data depending on which dynamic routing protocol you have used. Because in dynamic routing protocols too, we have OSPF, EIGRP, RIP, and each one takes data differently to the destination. Okay.
Yeah.
So that is our mesh topology. Then first, just give me 1 minute, guys. I'll be back in a minute.
Yep.
Okay, that is back. So let's clear this one first. So now we have the two remaining topologies, that is tree topology and hybrid. So if you understood all the rest of the topologies, then it will not be hard to understand the tree and hybrid, because they are just the combination of multiple.
Tree and hybrid.
Okay.
Yep.
But in today's this nobody be talking about nobody be using bus or star technology, bus and star, because of I don't know, there are more technologies now right now.
Yeah, mainly like if we combine bus and star topology, that the combination of bus and star topology is called tree topology. And in nowadays, if you are opening a company, then that company will at least have around what we say, at least 15 to 20 systems. Okay, so in that, it is almost negligible chances are there that you will only be using a single topology. In that case, you will be combining multiple topologies. You could be using bus, star, ring, and mesh. It might be possible that you have two offices nearby and you want to connect both of them privately, and you can use these. Okay. So first one is sixth, seventh. That is our tree topology. Which is also called expanded tree topology. Also called expanded tree topology. And why is that? Because it is combination of bus and star topology.
Yep.
And if you want to connect two star topologies in tree, in that case, there will be a bus topology in middle, in between of them. Okay. So let's wait a minute. The recording will, the session will stop. We'll start it again. Okay. It's almost 40 minutes. So let's do a 10-minute session after 5 minutes. Once it is done, then we'll start it again. Okay.